Hey guys, I just got done with my chem midterm, so I figured I'd get out a video for you guys. I know it's been a little bit, but I know you guys also like my math videos, so I'm cranking that out right now. I'm just gonna make this one on asymptotes. I'll probably go into hyperbolas, ellipses, circles, that sort of stuff, conics type stuff for you guys pretty soon here. But we just covered this topic in class, and a lot of people were struggling with it. I understand it pretty well. I studied a lot of this stuff over the summer too for fun, so I just kind of want to get this out to you while I'm still editing my gameplay footage. I decided to do an easy one today, just asymptotes, something super simple. But basically, the main things about asymptotes you guys need to know about is that for an asymptote, if it's on the horizontal axis, that means that it can't be crossed. Sometimes it can, and that'll leave a hole in it. Vertical asymptotes can't cross, it will start going to extremes at that point. Very rarely there will just be a hole in it. And slant asymptotes you can't cross, right? So first thing I'm going to cover in this video is just horizontal and vertical asymptotes and how to find that hole, especially because my teacher did not tell us how to find the hole for the asymptotes. It's very simple though, trust me, it's not that complex. I don't know why she didn't cover it. So the basic structure of any type of function that is going to be in a denominator format like this, like a fraction format, is remember that the first like x, so like if it's like x cubed, or like here where it's x minus 4, x squared minus 16, the leading x and the power that it's raised to are very important for finding these. So I wrote it down as this: the coefficient of x, so the number right in front of x, is a for the top one, the numerator, and the power that's raised to is n. And below that is the coefficient of b times x raised to the power of m, right? And then over here you guys can see I put down a little chart for you guys, so make sure to take a picture of this. This one's going to take practice. You're not going to just take it in after one video or even one lecture from a teacher. But a horizontal asymptote, if the n value is greater than the m, or is less than the m, so remember that's this value right here and this value right here. If the n is less than the m, then the asymptote will equal y equals 0. So it'll just be a straight line straight across the x-axis. So it'll just go right along with the x-axis. Very hard to graph, I know, but it's whatever. Just know the line should not pass through there. And then if the n value equals the m value, so if, like, for example, this is just a times x over b times x, no power raised to, it's just to the power of 1, then the asymptote will be at a over b. So that's these leading coefficients, just the ratio that those two are at. So if the front one's 1 and the bottom one's 2, then it will just be on the line of half. It will just be y equals half. So the y value across will equal half. I'll show you guys too on how that actually looks on the Cartesian plane, but very simple. Horizontal is one of the easiest ones to get. The even easier one is the verticals. So the vertical asymptotes, things start to act weird at vertical asymptotes usually. I'm not going to say anything definitive because I haven't read any proofs on what exactly happens, but they tend to go to infinity when you come across them. So they either go to negative infinity or positive infinity, or sometimes they'll even just like break or totally turn around and stuff like that. So weird stuff starts happening at those points as well. And those are just the zeros of the denominator. So if you guys don't remember what zeros are, it's just whatever the x value has to be to make that entire thing on the denominator 0. So right here, if I can find my mouse, you can see where like it's x minus 4 over x squared minus 16. So the zeros, you can factor them out, and remember what I showed you guys in the foiling example is x plus 4 times x minus 4 equals x squared minus 16, right? So then the vertical asymptotes would be negative 4 and positive 4. But hold on 1 second, that's not 100% true. And I didn't know this until a bit ago because my teacher never taught us this. But if the 0 of the denominator is 0 and the numerator is... Wow, that doesn't make any sense. Hold on, I need to fix this. A little commercial break. Alright, I fixed it. If the 0 of the denominator makes the numerator also 0, then there are no asymptotes, but there's a hole in the graph at that location. And I'll show you guys what that looks like in a bit. But for this one, basically what we'd see here is that the asymptote would be, I'm going to write this on the side where I'm not going to delete everything, so we'll see. Horizontal, I just write down HA, especially because I can't like write on this. I don't know if you guys can tell by that N. That N is crooked as shit. But the horizontal asymptote would be at, horizontal would be at y equals 0, right, for this one? Yeah, since the n, this right here, is just the power of 1, and that one's 2, so it's less than 2. So it'd just be y equals 0. Okay, just do a line to that. That's not theta, it's 0, I swear. And the vertical asymptotes would be at, -4, so it'd be x equals -4. Because you gotta remember how you're looking at this graph, right? So this is stating that the value of x is -4 for all of y values. That's what the asymptote is. And for the horizontal, it's y equals 0 for all of the x values across. So from -infinity to infinity. And I'll show you guys on the graph too what that looks like. It's very simple. It's just a straight line. It doesn't climb, it doesn't decrease. It's just a straight line across. And then it's usually good practice as well to also get the roots of the equation and the zeros for y, and all that sort of stuff, right? So the zeros for x and the zeros for y. For this one, it's pretty easy. If y equals 0, right, then we need -4, right? No, we need +4, and then so that'd make the numerator 0. So at the y, would it be? No, at the x-intercept, it's 4. X-int equals, and then make sure just to put in the actual point system, so writing it out correctly. Like whenever you mark down anything on the Cartesian graph, you should put it in this format. And then the y-intercepts would be if x was 0, right? So y-int would be, let's see here. Usually it's easier if you just take the original format that you get in where it's fully expanded. So that would just make this 0, so then you have -4 over -16, which would be, the negatives would cancel out, and then 4 over 16 is 1/4. So x-intercept is at, oh my gosh, my @ sign sucks on here. I'll actually get a tablet for you guys to make this easier. I know these videos specifically are very not edited too much just because I want to get them out to you, because this might be helpful for you, and this might be something that you're dealing with right now in pre-calc, and the teacher just might not be making sense. But anyways, the y-intercept would be 0 - 4. So this will help us know the behavior. Sometimes you got to plug in problems to see how it actually acts. So I'll show you guys what that looks like just right now. So basically this is what asymptotes do for you. It's that they help you make the graph that you're looking for. So this is exactly, what we were able to graph earlier. As you can see, this vertical asymptote, things go crazy. Like how I was telling you guys earlier, things went to positive infinity and negative infinity, but they never cross that line. So they just keep on getting infinitely higher y values and infinitely smaller x values at those points. And then once they cross entirely, they flip. This is actually, weirdly enough, a proof why anything divided by 0 is not infinity, but it's undefined. Is because because 0 is in this weird middle ground right here of it's either infinity or negative infinity, and we can't really tell. So that's why in most fields of math, we just look at 0 and say that's undefined. A little fun fact for you guys. But as you can see, this basically tells us exactly everything we need to know about this graph at this specific location. It approaches this line, the asymptote, the vertical, which was x equals -4. So approaches that line, goes to infinity and negative infinity, and that has a x-intercept right at y-intercept at 1/4 for us, so right down over here. And then there is a hole right in this location. It's actually at 1/8, so it acts a little bit weird. I'll tell you guys later how to find those specifically. But this basically breaks it down. Ignore that this line kind of goes up towards the end. I did not mean for it to do. It's forever approaching 0. So as long as it goes, it will just keep on getting smaller and smaller and smaller. It will never quite hit 0, but it's approaching 0. Because, it's like it hits 0, it's divided by 0. Yeah, so it just does not happen. But yeah, basically this is why asymptotes are so important. You'll actually see this more in calculus when you're finding derivatives and exploring the limits and that sort of stuff, like how close you can get to certain points. It actually will show you exactly what happens at these holes in the graph as well, by substituting where that hole is with A and so forth. But yeah, I hope this actually helped you guys a little bit. I'll be coming out with the Metal Gear Rising playthrough pretty soon. I was just recording it, and I'm about to start editing it. We'll see how that goes. That'll be my first gameplay footage. But for now, I hope this was very helpful for you guys. All right, see ya.